Hi, my name is Nadav Aitu from UCSF, and I'm one of the corresponding authors for this article on novel 13 base pair insertion in the sonic hedgehog limb enhancer causes preaxial polydactyly of triphalangeal thumb. So as geneticists, we're really good at finding genes, and if a certain sequence was a gene, we'd probably pick it up because genes have these rules. They start with an ATG, and with the TGA, they have exons and introns that we can figure out. However, regulatory elements are much harder to find, and we're also compounded that with the fact that 98% of our genome is actually non-coding, so we have this vast genomic space in which to search for them. In addition, for genes, we have a code, and we know the consequences of nucleotide changes to that code. But for regulatory elements, we don't have that. So even if I was to find a sequence that I know is a regulatory element and I find a mutation in it, I really don't know what it will do in terms of the phenotype. And that's a problem because these regulatory elements, if you have mutations in them, they could also lead to disease, such as the example that we have here in this article. The main regulatory element that we're going to discuss here in the article is an enhancer. Enhancers are sort of the promoters of the promoter that tell the promoter when to turn on, at what location, and at what amount. And we have this well-established enhancer assay in the lab where we take a sequence that we think is an enhancer, stick it in front of a minimal promoter and a reporter gene. And a minimal promoter is like a light switch, so it's always off. If it has an enhancer in front of it, turns on the switch, and then that turns on your reporter gene. And when we inject that into transgenic mice, we can look at where that reporter gene is expressed. In the case of mice, we usually use LAC-Z. So can mutations in limb enhancers actually lead to human limb malformations? Well, one very nice example, as discussed here in this article, is the sonic hedgehog limb enhancer. So mutations in the gene sonic hedgehog lead to holoprosencephaly, limb, cyclopia, a lot of bad things. And then 1 megabase away, 1 million base pairs away, is the sonic hedgehog limb enhancer. You remove it in mice, you get this limb truncation phenotype. And if you look at patients with preaxial polydactyly, a lot of them can have mutations in this enhancer that lead to this extra finger phenotype. And so in this article, we had a large Swedish family with preaxial polydactyly and triphalangeal thumb, and that phenotype reminded us of the sonic hedgehog limb enhancer. And so we sequenced that enhancer, and we found a new class of mutation in this enhancer, a 13 base pair insertion. Until now, no insertions mutations have been found in this enhancer. Then we wanted to see what this insertion brings along for the ride, and when we looked at that, we saw that it inserts a lot of limb-specific transcription factor binding sites, primarily in two positions that you can see here. And interestingly, it doesn't abolish any transcription factor binding sites that at least we could see. We next wanted to see what it does in terms of function, and so we did the enhancer assay that I mentioned previously. And when you do that on a wild-type sequence, you see that you get expression of the enhancer only in the posterior portion of the limb. When we did that with the 13 base pair insertion, we got ectopic expression of the enhancer, and specifically not only in the posterior portion of the limb, but also in the anterior portion. So to sum up, we found a novel class of mutation in the sonic hedgehog limb enhancer, a 13 base pair insertion. This insertion we think brings along a lot of limb-specific transcription factor binding sites, and functionally what we think is happening is now sonic hedgehog is being expressed also in the interior. And if you want to learn more about our study and our specific limb malformation study, trying to find mutations, we have a study brochure and a dedicated study website that you can go into and see if you're interested in participating. Thank you.